Hey guys, this is your homework video for Wednesday night. I noticed when I looked over a lot of y'all's tests that you missed number, I think it is 9. It had fractions and you had to subtract fractions. And I'll just show you as we get there, but there is an issue with how some of you guys solved it. I saw a consistent mistake that I want to help clear up for the homework. So this isn't the exact same problem as what it was on the test, but it's something similar. And let me show you what I noticed. Okay. We understand that we need to find a common denominator. Hopefully by now, when we subtract and add, we find a common denominator. And if you don't know what that is, you can do that little chart, remember? Count by your 3's, count by your 4's until you find a match. Boom, 12. So then you make this 12, you make this 12. I would multiply this 3 to get to 12 by 4. 1, 2, 3, 4. So I multiply this by 4 and you get 4, obviously. So this is from 3 1/3 to 3 4/12. Same fraction, just not simplified. Here, we're going from 4 to 12. 1, 2, 3, that's how many 4's I need. So I'm going to multiply this by 3 and multiply this by 3. 3 times 3 is 9, and keep my whole number there. All right, this is what I saw, and this is what I want to help fix. And I'm going to show you 2 ways to where we can eliminate those mistakes. Hopefully, that's the goal at least. As you saw, we're subtracting, so we did 3 minus 1, and you did 2. No problems there. But then you looked and you said 4 minus 9, and you said 5. You circled that as your answer. This is wrong. Because you said that 4 minus 9 is 5. And that's not true. Here's what I want to show you as a visual. You've learned this a lot. To say that you can do 4 minus 9 is the same thing as saying that 0 minus 5. Ooh, actually, that's not a good example. Let me scratch that. I want to change that up just a smidge. Saying that 4 minus 9 is 5 is the same thing as saying 0 minus 4 is 4. And that 7 or 8 minus 1 is 7. That's wrong. Why? Because we know that when we have something that's smaller than what we're subtracting by, we have to borrow. And that's what we failed to do here. We can't do 4 minus 9 and get 5. You can't do that. You have to do something called borrowing, which is what I'll show you down here. Or you can do what I've showed you in class. Some of you guys like it, some of you guys don't. I'm going to show you both ways. And then just pick which one you like better, which one makes most sense to you, and stick to that, all right? But let's just get down to it. So I'm going to rewrite the fractions. We know that we need to find a common denominator. I went ahead and did that here already. So let's just go ahead and change our fractions to this. Boom. And one way you can do this is just making the fractions improper. I've shown this a lot in class. The way you do that is you take your denominator, you multiply it by your whole number, and then you add your numerator on top of that. So 12 times 3 is 36, and 36 plus 4 is 40. Oh, shoot. 40 over 12. Keep that denominator the same. And then I do the same thing here. You do 12 times your whole number, which is just 12, plus your 9. If you're adding that up, please don't use your fingers if you can. But 12 plus 9 is 21. Okay? Now I can subtract this as normal. 40 minus 21. If you don't know what that is, we just go over here, do a little subtraction. We can't do 0 minus 1, so we make that a 10, make that a 3, because we're borrowing. You get 9, you get 1, we get 19 over 12. This would be my answer However, with fractions, what do we have to do? Simplify. So I'm going to come over here. I'm going to do 19 divided by 12. That goes in there once. I get a remainder of 7. What do I do with this 7? Make it into a fraction. Bring it up top. You got 1 and 7/12. And that is the same thing as 19 over 12. 1 and 7/12. Okay? That's how I've showed it to you in class. Some like it, some don't like it. So now we go here. And we try another way. This one I haven't shown in class. This one I actually think is much easier. It's just a little bit harder to explain in front of a whole class because some kids just don't get this at all. And that's okay. But I'm going to show you anyways, so if this is confusing, you can just do this that I've been doing in class. First thing is we've got to find common denominators. Oh look, we've already done that. Haha, don't need to do that. Okay, just common denominators there, boom. Now, again, we talked about this. You can't do 4 minus 9. That doesn't make 5. If you had 4 apples and I took 9 away from you, is that even possible? No. I can only take 4 since you only got 4, right? So we can actually do something called borrowing. And what we do, just like in this right here, let's go back to that example. I'll do this down here. We can't do 0 minus 4. That doesn't work. So you've been taught to make this into a 10, and we're allowed to make this to a 10 because we're taking from our 10's digit place, our 10's value. Making that 7 10s, and taking one of those 10s and putting them over here. So then we do 10 minus 4 is 6, 7 minus 1 is 6. And that's the real answer there. Really, it's the same process here. It's just going to look a little different because it's fractions. I can't do 4 minus 9, so I'm going to borrow from this whole number and make it a 2. Now, how does that help here? Well, let's think about what a whole number is. If I have 4 over 4, what is that? 1. 4 divided by 4 is 1. What about 5 over 5? Still 1. So a whole number as a fraction is the same numerator as the denominator. See that pattern there? Same numerator as the denominator. So what I can do is I can add 12 to my numerator here. Because 12 over 12 is a whole number. And so I'm going to do 4 plus the 12 that I'm adding as a whole number and make this 16. Now I can subtract. My whole number, 2 minus 1 is 1. 16 minus 9 is 7. And we keep our denominator the same. And oh, look, we get the same answer. Boom. Now, if you're like, Mr. Bass, this part didn't make any sense, can you just show it to me in a better way? Sure, I'll try. Let's think about how this is with pizza, because pizza is life. We have 3 wholes. Remember, we're using this fraction here. And we got 12 pieces. So how am I going to do that? 1, 4, that makes 8. Yikes. We're going to call that 12. I know it's not perfect because I'm not an artist. You guys know that by now. We have 3 and 4 12s. So I'm going to shade in 4 12s to the best of my ability. Let's pretend that's a good solid 4 12s. We're subtracting 1 and 3/4, which we converted to 1 and 9/12. So I'm going to do 1 whole pizza and 9 12s. Good luck with that. At least I'm making it. Oh, shoot. Boom, we're going to do that. We're gonna do a little bit of that, and we're gonna pretend that's 12 equal pieces. And I'm gonna say 9 of them. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Sure, let's go with that. Okay, so I can easily take away one of these, right? When we're subtracting, we'll take this away. And I can't take this amount of pizza away from this amount of pizza, right? This is more than this. So what do? We say, well, let's combine this together so that we can actually take this away. So that 3 and 4/12, we can call it 2. It's the same as 2. And this is 12 pieces right here, 12 whole pieces. And 1, 2, 3, 4 more pieces for a total of 16 out of 12. We're combining this together to make 16/12. So my 2 whole, 12 plus 4 is 16. Just like I did here. 2 and 16/12, 2 and 16/12. And then I can subtract that from 1 and 9/12. Getting me 1 and 7/12 as my answer. Again. Boom, boom, boom. Okay? If this visual is any help at all, please tell me when I come back to class on Thursday. If it's not, then I'll try to come up with another visual for you guys and maybe spend a little bit more time on it in our bell work. How about that? Okay? Bring this back tomorrow.